In this video, we're going to look at finding the Taylor series of f of x is equal to sine x centered at x equals pi over 6. Let's start by taking some derivatives. But before doing that, we're going to need a special triangle. So we need the 30, 60, 90 triangle. The smallest angle, which is pi over 6, is opposite the smallest side, which is 1. The medium angle, which is 60 degrees, that's pi over 3 radians, and that's opposite the medium side, which is root 3. And the largest angle, which is 90 degrees, is opposite the hypotenuse, which is 2. All right, so f of x is equal to sine x. Now let's evaluate the function at x equals pi over 6. So we have f of pi over 6 is equal to sine of pi over 6. And looking at the special triangle, sine of pi over 6 is sine of 30 degrees. That's opposite over hypotenuse. That gives us 1/2. Now differentiate. We get f prime of x is equal to cosine x. Evaluate the derivative at pi over 6. So we get f prime of pi over 6 is equal to cosine of pi over 6. And cosine is adjacent over hypotenuse. So cosine of pi over 6 gives us root 3 divided by 2. Now f double prime of x, let's differentiate cosine x. We get minus sine x. Plug in x equals pi over 6, and we get f double prime of pi over 6 is equal to minus sine of pi over 6. And we know sine of pi over 6 is just 1/2, so we get negative 1/2. Now differentiate again. We get f triple prime, the third derivative of the function, and derivative of sine x is equal to cosine x times negative 1, so we get minus cosine x. Now evaluate at pi over 6. F triple prime of pi over 6 is equal to minus cosine of pi over 6, and we found cosine of pi over 6 to be adjacent over hypotenuse, root 3 over 2, so we get minus root 3 divided by 2. Now differentiate again. The fourth derivative, f4 of x, is equal to sine x, because derivative of cos x is negative sine x times negative 1 gives us plus sine x. Evaluate at pi over 6, so we get the fourth derivative, f4 of pi over 6, is equal to sine of pi over 6, which we know to be 1/2. And all the derivatives will follow in a cycle, because you can see how we started with f of x equals sine x. Now the fourth derivative is sine x. So the fifth derivative will be like the first derivative, cosine x. The sixth derivative will be like the second derivative, minus sine x, and so on. All right, so let's list some of these derivatives. F of pi over 6 is equal to 1/2. F prime of pi over 6 is equal to root 3 divided by 2. F double prime of pi over 6 is equal to negative 1/2. F triple prime of pi over 6, the third derivative, is equal to minus root 3 over 2. The fourth derivative, f4 of pi over 6, is equal to 1/2, and so on. Now, the pattern is clear. The even derivatives, that means f of pi over 6, f double prime of pi over 6, f fourth of pi over 6, f6 of pi over 6, f8 of pi over 6, all the even derivatives are alternating between 1/2 and negative 1/2. While the odd derivatives, f prime of pi over 6, f triple prime of pi over 6, the fifth derivative of pi over 6 are alternating between root 3 over 2 and minus root 3 over 2. So we have a pattern. We have developed a pattern. Now we just have to get a formula for it. So the pattern is clear. The even derivatives alternate between 1/2 and negative 1/2, and the odd derivatives alternate between root 3 over 2 and minus root 3 over 2. So the formula for the Taylor series of any function is, so sine x, that's our function, sine x. This is equal to f of pi over 6 plus f prime of pi over 6, because our center is pi over 6, so we evaluate the function and its derivatives at pi over 6, times x minus pi over 6, divided by 1 factorial, plus f double prime of pi over 6 times x minus pi over 6 all squared, divide by 2 factorial, plus f triple prime of pi over 6 times x minus pi over 6 to the power of 3 divided by 3 factorial, plus the fourth derivative f4 of pi over 6 times x minus pi over 6 to the power of 4 divided by 4 factorial, and so on. Now let's place these derivatives inside and try to find a formula for the Taylor series of sine x at x equals pi over 6. So we have f of pi over 6 is equal to 1/2. Let's rewrite that. F prime of pi over 6 is equal to root 3 divided by 2. F double prime of pi over 6 is equal to negative 1/2. F triple prime of pi over 6 is equal to minus root 3 divided by 2. And the fourth derivative, f4 of pi over 6, is equal to 1/2. And if we found the fifth derivative, it's just a cycle, so it's going to be the fifth derivative at pi over 6 is simply going to be the same as the first derivative at pi over 6. So it will be just root 3 divided by 2. And similarly, the sixth derivative at pi over 6 will be the same as the second derivative of the function at pi over 6, negative 1/2. And the seventh derivative, f7 of pi over 6, will be the same as the third derivative at pi over 6, because after 4 derivatives, the pattern just repeats itself, minus root 3 divided by 2. Now, I know I'm doing this again, but this is just to emphasize the fact that the even derivatives, f of pi over 6, f double prime of pi over 6, f4 of pi over 6, f6 of pi over 6, the even derivatives alternate between 1/2 and negative 1/2. And the odd derivatives, f prime of pi over 6, f triple prime of pi over 6, f5 of pi over 6, the fifth derivative of pi over 6, and f7 of pi over 6, they alternate between root 3 over 2 and minus root 3 over 2. So let's write down the Taylor series of sine x, then we'll develop the formula for the pattern of the Taylor series. Sine x is equal to 1/2 plus root 3 divided by 2 times x minus pi over 6 divide by 1 factorial plus, let's write that as minus 1/2 times x minus pi over 6 all squared divided by 2 factorial minus root 3 divided by 2 times x minus pi over 6 to the power of 3 divided by 3 factorial plus 1 over 2 times x minus pi over 6 to the power of 4 divided by 4 factorial. So we're now going to separate the even and odd powers of x. So we can write this as sine x, and this is the step that's a little bit tricky. Sine x is equal to n equals 0 to infinity. We need something that alternates plus minus, because the even derivatives alternate between 1/2 and negative 1/2. And the odd derivatives alternate between root 3 over 2 and minus root 3 over 2. So we're going to use negative 1 to the power of n. We need to generate even powers of x. So that's going to be x minus pi over 6 raised to the exponent 2n divided by 2n factorial. And don't forget the 1/2. There is divide by 2. Plus, so this part is the even powers of x. This is the even powers of x. This takes care of this part, 1/2, this part to the power of 2, this part, and all the even powers of x. Now, let's look at the odd powers of x. Summation, n equals 0 to infinity. We need to generate plus minus, so again, we use negative 1 to the power of n. And root 3 over 2, we're going to need this, times x minus pi over 6 to the power of 2n plus 1, all divided by 2n plus 1, let's squeeze that in, 2n plus 1 factorial. And this is the odd powers of x. this summation takes care of the odd powers of x. And now we've written the Taylor series of sine x with center pi over 6 as a formula involving even powers of x and odd powers of x. All right, so we've written sine x as summation n equals 0 to infinity minus 1 to the power of n times x minus pi over 6 to the power of 2n divided by 2 times 2n factorial. That's all the even powers of x minus pi over 6. And the odd powers of x minus pi over 6, we've written that as summation n equals 0 to infinity minus 1 to the power of n times root 3 divided by 2 times 2n plus 1 factorial times x minus pi over 6 to the power of 2n plus 1. So we have found a Taylor series of sine x centered at x equals pi over 6. And of course, you have to know the 30, 60, 90 triangle. We use this triangle to evaluate sine of pi over 6 as 1/2 and cosine of pi over 6 to be root 3 divided by 2. All right, thanks.